So let's talk about where you might see a parabola and a focus point. So the book talks about something interesting here. It says parabolic reflectors have cross sections that are parabolas. So this would be a parabolic reflector, and if you cut across the front of it, you would see a cross section of what's inside. A special property of any parabolic reflector is that all incoming rays parallel to the axis of symmetry hit the reflector and are directed to the focus. So, for instance, if you have a ray that comes in and hits that, it's going to go right to the focus. So any ray that comes in like this hits off the side of the parabolic reflector and right up to the focus point. Same thing happens. Anything you have at a focus point, when it emits out and hits the reflector, it shoots off into parallel lines this direction. Similarly, rays, okay, we just talked about these properties are the reason satellite dishes and flashlights are parabolic. Maybe you've seen, if you drive out into the country or maybe even on top of some roofs in town, you might see satellite dishes, and those satellite dishes are in the form of a parabolic reflector. So the cross sections would be parabolas. And so what happens is the rays, the TV signals come in, and when they hit, they all go to the focus point, which then directs into the house. Same thing with a flashlight. If you unscrew the lid off of a flashlight, you'll look inside there, and this is the shape of a parabola. So the light bulb is here. When the light bulb shines out, it hits that reflector and then forms some kind of, over here, if you look on the ground, there's going to be like an ovally kind of looking light. It's all going to come straight forward in this one area. So flashlights are in the shape of a parabolic reflector. Your headlights on your car would be the same thing. Let's talk about a problem here. Oh, also, if you go in Walmart or some kind of store like that, if you look up in the corner, you'll see some kind of camera, and that camera has usually got a parabolic reflector in there. So the camera is right inside, and you can see all angles right back to that one spot. So that's what this problem's about. A store uses a parabolic mirror to see all the aisles in the store. A cross-section of the mirror is shown. Let's write an equation. So here's what happens. I know that there's a point right here at 8, 2. So let's see if we can write an equation. I know that this one faces up, so it's going to be a y equals x squared equation. And if I'm thinking about the focus, I'm going to say 4py equals x squared. I know that there's a point on this parabola where y is 2 and x is 8. So 8p equals 64. So p is 64 divided by 8. So the focus point is going to be at 0, 8. All right, now that we know p, let's write a general equation. 4py equals x squared. And if p is 8, we know that 32y equals x squared. So y equals 1 over 32x squared. What you'll notice is the bigger the focus point, the farther away it is, the wider this parabola is going to be. So this equation would be y equals 1 over 32x squared.